Okay, first video on random sampling. This is just the background. So we're going to look at the nature of samples, and the first thing we're going to look at there is a sample is actually defined as a subset of a population. So it's part of a population. So the whole population, so the group of interest is defined as the population. It might not be everything that exists out there, but it's everything we're interested in. A bit like the universal set when we're doing Venn diagrams, you might recall that, a little bit like that. So the population is everything in consideration, and the subset of that is called a sample. So when it's not feasible to survey or crunch the data and analyze things around the entire population, we're tending towards taking a sample, okay? And a census is surveying or analyzing the entire population, whereas a sample is part of that. So that might be due to resources being limited, such as time and money and access and so on. And a sample has a few things it must be. It must be representative of the population, so it must accurately represent the greater population. We must be confident in that. Now we use capital N as the notation for the number of elements in the population, but lowercase n for the sample size. It's preferable usually to take multiple samples. That way we can check for validity and consistent results, and also the sample size itself matters. It needs to be sufficiently large. Well chosen samples are very, very important, and we're going to focus in particular on simple random samples and other sorts of random sampling. And the statistics from the samples allow us to gauge confidence in the sample, and we want to see and be confident that it's valid, okay, before we make use of the data from that sample, and so the predictions and decisions around that need to rely on a valid sample. A few little definitions here. We've got a fair sample is one that is representative of the population, and that's fairly self-explanatory. It's called a fair sample. Okay, its characteristics are reflected in the entire population, or the sample's characteristics are consistent with the entire population. And at the other end of the scale, we might have a bias sample, which is not representative. The random sample ensures that every member of the population has an equal chance of being chosen. You might have heard that before. So for example, one I've personally heard as a school teacher is when I've given the students a survey to design, and they chose to do it on attitudes about health and physical education for adolescent people. They've gone around the school and they've claimed to have done a random sample, but they've stuck to the school oval as their site for sampling, and that's going to create bias. Okay, so it's not a good place to well, as your only place, it's not a good place to be to get attitudes about physical activity and so on. Different subgroups present in the population appear in the sample in similar proportions. Okay, sometimes they're called strata, but we're probably not going to use that word too much. But subgroups, subpopulations, if they have a fixed proportion in the population, they should have the same proportion in any sample taken. So we'll extend on these ideas in the second video.